I'd like to introduce you a case study here in Holland. We have a problem, for example, with Zwolle-Kampen. It's a small area, one of, say, 13 kilometers of track. What's the problem over there is that when the train is going over that track, it will give a huge waves because of the soil problem. So the foundation of this track is not okay. And why this happened is that we transfer and refurbish the train operation from 100 kilometers an hour into 140 kilometers an hour. So what went wrong in this case? The problem is that when you have this upgrade of a train track, you have to be aware of the problem of the water and the soil situation. So you have to go back for many centuries to see what was the water flow in history. And therefore you have to go back into the old maps and see, and then you see and you discover that Kampen and Zwolle are more or less sandy areas, and in between it's one big swamp, like oat. And that's not so heavy and not so good foundation. So when you don't change this characteristic of soil, you don't have the right foundation, and you get these big waves, and therefore you get all waves moving all the parts and the assets you have on the track. So what is the lesson learned here? Be careful, and before you start with the refurbishment of a track, always go back in history and look also to the ground and the water management over there too. I'd like to introduce another case we have in Holland, and we have also a high-speed line. In the high-speed line we have, of course, a high-speed train, and this train has to cross a big river in Holland. The problem is that after a few weeks, we get a lot of problems when there was some stormy weather. And we have a lot because we are a coastal area, and therefore we get all these windy flows. How to handle this? Because the train could not pass with 180 kilometers an hour, even when you like to drive 300 kilometers an hour. So what to do? So you can think about, okay, we stop and we lower the speed, but that's not an option because we have a high-speed line. So we have to do something else. And therefore we had to find out afterwards that we have to make some barriers to block the wind. And therefore we did this option, and we also implement this. But why didn't we discover this beforehand? That we know before that when a train was passing a bridge, that you have these problems at the beginning. So that was also a lesson learned, how to catch this problem ahead. And therefore you need much more discipline than not only the civil engineer or the mechanical engineer or the rolling stock engineer to find the right system. You have to find a wider focus, and also to take into account the weather conditions, especially on this bridge. Another case I'd like to show and to tell about is the problem we had with the Vira train. It's a high-speed line train, and it was a combination with Belgium and Holland to make this happen. And we liked to have an original train, and therefore we ordered this one as a country, and we did the first runs with the train. There we saw a lot of baby illness of these trains, and you could say, what happened? Normally, when you have a train and it is brand new and also a new design, you have always baby illness. So you can do two options: or you stop with this, or you say, okay, I will solve this baby illness in time. Because all the trains we have all over the world, we have always baby illness. And normally it will take 1 or 2 years to survive that. That's normal. But in this case, we decided, that's a political one, just to stop with the train. And I think there were more problems than just baby illness. And that's the problem we had with this Vira train, because we like to have a really cheap train. And we succeed in that. We have a really cheap train. It was cheaper than an ICE or a Thalys or TGV train. But what did we get at the end? And I think this design problem was because of the contract. We only focus on the contract, must be cheap, must be high speed, and let's go for it. And the lowest price wins the bid. And therefore we have also a train with the same quality and the budget in that balance. I think when you like to solve this, you have to be very aware of the practical situation outside. And how do you do this and transfer this into a contract? And then that's also system engineering, not only on the technical side, but also on the practical and operational side. So what I like to say as a conclusion to you is that we can see that design in railway engineering is really important to manage all the knowledge and also all the disciplines we have in this railway engineering. You need all this knowledge, and you have this system approach, otherwise you don't have these right specifications in the beginning, and therefore you miss all the facts you need to have a full performance of your system. So designing is really important, and also in an early stage, so you don't have to do refurbishment at the end. So in this course you will learn how to do this, and this design is what it's all about.